Hi guys, I thought I'd make this recording so you had it over the weekend if you're struggling with these ALEKS questions. Let's go through each big idea that you have to learn. Alright, understanding the prefixes used in naming binary compounds. So this is just given a name in words, you have to come up with the chemical formula. You have to look at the prefixes and the elements. Feel free to use that prefix chart that you have in your notes. Otherwise, if you don't have it handy, you could look up online molecule prefixes, and there's tons of pictures for them all over online. So here we go. Pentasulfur dinitride. You've got sulfur, and pent is 5. Nitride is nitrogen, and di is 2. Sulfur diiodine, that means I have 2 iodine. Sulfur monochloride is 1 chloride, and sulfur tetrachloride is 4 chloride. Check your answer, and then ALEKS will give you another one with a different chemical. In this case it's phosphorus and sulfur. Go through the same pattern. Next idea, counting bonding and non-bonding electron pairs. When you do these problems, you have to read from what atom you're looking at. So this one right here, this is the structure for methane. They want the number of bonding pairs and the number of lone pairs around the carbon atom. So I look at carbon, and it's surrounded by a shared pair, a shared pair, a shared pair, and another shared pair. So there are 4 bonding pairs. Where it bonds with hydrogen, it doesn't have any lone pairs. The next one, I'm supposed to look at the bonding and lone pairs around the top hydrogen. The top hydrogen has right here 1 bonding pair, but it doesn't have any lone pairs, so that's 0. Now if they were asking for nitrogen, nitrogen has a lone pair, a pair that's not bonded, but they're asking for the hydrogen atom. And then the last one here, bonding pairs for the oxygen atom would be 1, and the lone pairs are 1, 2, 3. Those are the pairs that it doesn't share with anything else. All right, next idea. Naming binary covalent compounds. It's not going to let me get to that until I pass this. So let's quickly go through these. Tetraphosphorus, hexasulfide, hex is 6, tetraphosphorus, disulfide, di is 2, diphosphorus, pentasulfide, phosphorus, disulfide, and I'll have to pass one more. Dinitrogen, I have nitrogen, di is 2, tetraoxide, oxygen, tetra is 4, nitrogen dioxide, di is 2, nitrogen monoxide is just 1 O, dinitrogen monoxide is N2O. All right, let's go to the next one. Naming binary covalent compounds. So now we're doing the reverse. They give us the formula, we have to come up with the name. So phosphorus, use the element name, and then the second element has to end in "ide", so sulfide, but we have to have the prefixes. 4 is tetra, 7 is hepta. Nitrogen, trifluoride. And remember to spell fluoride right. F-L-U-O-R-I-D-E. A lot of people put O-U. Dinitrogen, tetrafluoride. I spelled fluoride wrong up here. Tetranitrogen trisulfide, and I've discovered for H2O they don't want dihydrogen monoxide, they want the common name water. So you can put the common name water for H2O. Next one, whether a Lewis structure satisfies the octet rule. So when you satisfy the octet rule, you have to check two things. You have to check that you have the right number of electrons, and you have to check that those electrons are ranged so each atom has 8 electrons around it, unless it's hydrogen that only wants 2. So you might find it handy to look at your periodic table. Nitrogen is in the 5th group here, 5A. It has 5 valence electrons. Oxygen has 6, chlorine has 7. So I've got 5 electrons, 6 electrons, 7. 5 plus 6 is 11, plus 7. I should have 18 electrons represented. Let's count. 2, 4, 6, 8, 10, 12, 14, 16, 18. We have the correct number of electrons. Now we have to see that they're arranged so there's an octet, or 8 around each. 2, 4, 6, 8 around chlorine. 2, 4, 6, 8 around oxygen. Remember, each bar represents 2 electrons that are shared, but I only have 2, 4, 6 electrons around nitrogen. So it has the right number of valence electrons, but it doesn't satisfy the octet rule. So I would check this box, and the problem atom is nitrogen, which only has 6. Let's look at this one right here. I have chlorine, carbon, chlorine, and oxygen. I look at my periodic table. Each chlorine has 7 electrons. Carbon has 4 valence electrons. Oxygen has 6. 4 plus 6 is 10. 2 sevens is 14. I have 24 valence electrons. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. We have the right number of valence electrons. Now we have to make sure that each element has 8. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. This one follows the rules. Here's H2O. So H2O right here has a problem. It has hydrogen sharing 1 with oxygen and 1 with the other hydrogen. But hydrogen only has 1 electron. It can't share 2 electrons. So we have to, first we're checking 2 things. Is there a right number of valence electrons? Again, I look at the periodic table. Oxygen has 6. Each hydrogen has 1. So 6, 7, 8. I should see 8 electrons represented. 2, 4, 6, 8. 8 are represented. It has the right number of valence electrons, but it doesn't satisfy the octet rule. Oxygen doesn't have 8. Hydrogen has too many. The symbols of the problem atoms are hydrogen and oxygen. Finally, carbon monoxide. Carbon has 4, oxygen has 6. We should have 10 electrons. 2, 4, 6, 8, 10, 12. It has the wrong number of valence electrons. It should only have 10. All right, let's see if it will unlock the next one. Predicting the compound formed by two main group elements. So you have to predict whether it's ionic, molecular, or neither. Remember, you can do this by looking at your periodic chart. If an element comes from the left side and another one comes from the right side, the electron negativities are going to be large. It will be ionic. It's molecular if it's two nonmetals. So here we go. Open your periodic chart. I'm looking at aluminum. So aluminum is over here. It's a metal. Potassium is right here. We haven't had an opportunity to have two metals interact. We've had a metal and a nonmetal. We've had two nonmetals, so that would be neither. Potassium and sulfur. Here's potassium. Here's sulfur. A metal and a nonmetal would be ionic. And then they want the compound. Potassium has a charge of 1. Sulfur has a charge of 2. So I'm going to need 2 potassium to 1 sulfur. And xenon and radon, oh, xenon, it's a noble gas. It doesn't react. So I would click neither there. And let's check our answer. There we go. Let's see if it will unlock the next pair. Counting electron pairs in a Lewis structure with double or triple bonds. So here's our example. The Lewis structure of carbon dioxide. So oxygen, remember, has 6 valence electrons. Carbon has 4. Count the number of bonding pairs and the number of lone pairs around the carbon atom. So carbon, all 4 of its electrons are being shared. This one, this pair, and this pair. So carbon has 4 bonding pairs. It doesn't have any lone pairs. So 4 bonding pairs, no lone pairs. So here we go. This is the Lewis structure for C2H2 molecule. The number of bonding pairs and the number of lone pairs around the right hydrogen atom. I go to the right hydrogen atom. It only has 1 pair of electrons right here that it is sharing with carbon. It doesn't have any lone pairs, so there's not a pair of electrons here, here, or here. And we check our answer, and it's good. Let's look at another one. This is CH2O. Count the number of bonding pairs and the number of lone pairs around the oxygen atom. So I look at oxygen. It's got 2 lone pairs. Those are these pairs here that don't bond with anything else. And it's got these 2 electrons that it shares with carbon. Carbon sharing 2, oxygen sharing 2. I have 2 here and 2 here. That's 4 electrons, but they just want pairs, so it's 2 pairs that it's sharing. And I think do we have one more left? Predicting the single bonded molecular compounds formed by 2 elements. Now that one's not going to unlock, so I'll send that in a different video. I want to get that out. I'm going to have to go through and do all these before it unlocks that. Hopefully this will help you out. If you guys have any other questions, let me know. We will also work on this a little bit Friday in class.